GPT-4 Auto Scientist takes in a list of URLs like Wikipedia articles, archive papers, or any other URL in any combination, and iteratively goes over them and extracts essential information from each document, at each iteration adding to this essential information list, and at each iteration tries to come up with novel and original ideas. For example, when I gave it these two large language model papers, it generated these ideas: butterfly orthogonal neuroevolution strategy. I asked it to generate up to 3 ideas, but you can modify the generate as many as you like. Here I have the OpenAI cookbook for the new DALL-E 3 vision and covering some of the newer features. We can run it with these URLs as an original demonstration. Let's just run it. When we first run it, we get a default request which says generate original and novel ideas based on this information while combining most of the elements from the information. You can change this request, but we're not going to. You can actually put in your own. So as you see, we are now extracting the information from URLs by scraping them, and then we are using the JSON mode, by the way. We are setting the response format to return JSON object. So we are getting a list of 10 essential information from each one of the lists, each one of the URLs in the list. And after that, we are going to generate ideas. For example, this was about DALL-E, and it's coming out with interactive storybook platform, DALL-E 3 enhanced virtual real estate staging. And it's going to write all of these into files as well. As you see, we have written the first extracted essential information from the first file. By the way, I am allowing shuffle. So each time you run, the list is actually shuffled. You can set this to false if you want them in order. So it first extracts the essential information and then generates the ideas and writes them to file. And it keeps doing this at each iteration, depending on however many URLs we have, and it keeps writing them to file. As you see, now we have actually added the GPT vision, extracted the information, and we have created new ideas based on that. As you see now, we are combining DALL-E 3 with GPT-4. So this is how it works in a nutshell. You can have any type of URLs. I'm providing these as examples, but you can actually customize it any way you like. Let's talk about the code now. Also, these files will be available at Patreon at the $50 tier. Link will be in the description. We have 2 essential files. One is content-extractor.py, which is a class called content extractor, which extracts content from either a URL or an archive. The reason there's a difference is because archive files are PDF files. So essentially, it can be archived, but it can be any PDF document. But currently, the extract content method is checking if archive.org is in the URL. You can modify this if you are going to extract PDF files from any other source. The content extractor has 3 methods: extract from archive, extract from URL, and extract content, which drives them both. Requirements for this file are as follows. We are using Beautiful Soup for scraping and PyPDF to extract the content from PDF files. So when we run this file, we will run the extractor's extract content method, which is going to take in a URL list of URLs. And it's going to check for each URL if archive.org is in the URL, then it's going to call the extract from archive method. Otherwise, it's going to call extract from URL, append each extracted text into the new knowledge list and return it. So when extract from URL is called, we call Beautiful Soup. We call request to get the URL, call Beautiful Soup to actually extract it, and we look for paragraph, section, article, and code tags. You can actually modify this to if you are actually scraping some kind of a different website which might have its text content in divs, for example. But this is generally speaking what we're looking for. So we go through each tag, we combine the text elements from each, we make sure we place non-alphanumeric characters in the text with a space, and then we join them and return them. And similarly, when we are extracting from archive, we get the content with requests from that URL, and then we use IO to create a bytes.io object, and then we use PyPDF reader to get the content, and we go loop over each page of the PDF and add them to our content, and eventually we split the text, and then we return it by joining them. We do set a max words count, so we are both when we are extracting from URL or from archive documents, PDFs, we are actually extracting the first 30,000 word. GPT-4, the new GPT-4 has 128K context limit, but We do want to be mindful. Of course, 30,000 words is quite a lot. Probably almost all archive papers will fit in there, but feel free to modify this. So this is our class, and we have the name main functionality here. This will run if we run the script directly. The reason why we have this is for testing purposes. For example, if you run this, then it will actually extract all the text from this URL list and then save it to content.txt. And I have this count.py file, just simply to count the number of words. These are for informational purposes only. Well, essentially what we want to do is come to our main autoscientist.py file, and we are importing our content extractor class from the content extractor.py file. And when you import a file, it actually runs the file one time. This is why we put this if name equals main condition, so that when we're importing, this won't run. Only when we run this file directly, it will run. This is for also good for debugging purposes, or if you want to run this file's functionality on its own. Like I said, the code files for this will be available for Patreon members at the $50 tier. I have over 160 projects over there. And if you're wondering what type of projects, you can go to my website, ecohive.live, and browse over it or search for the content you're looking for. And if you're a patron, you can easily find the code download links. Let's take a look at our main file, autoscientist.py. We are using the latest version of OpenAI library. I believe I haven't updated it, but we are using the 1.1.0. We do import the content extractor. From content extractor, we set our API key and we set shuffle to true. When shuffle is set to true, these URLs will be shuffled so that each time you run it, you might get a better or newer idea. You can actually set this to false if you wanted to process them in order. And then we define our class content and idea generator with our API key, which we have defined right here. We initialize the client, OpenAI client, and we instantiate the content extractor as the self.extractor. And we created another method, which is going to take in the URL list and extract all of its contents using the extractor's extract content method. Then we have extract essential information method, which is going to take in some content. We are calling GPT-4 1106 preview. We set the response format JSON object, and we will use streaming responses. And our system message is as follows: you're a helpful assistant which extracts up to 10 essential information from a given text and return your answer as a list in JSON format always. And then we specify the JSON format right here. We want a list with the key extracted essential information returned as a JSON object. When you use the response format as the JSON mode like this, you do have to specify in your system message to instruct the model to return as JSON. Otherwise, your call will fail because OpenAI checks if JSON is mentioned in your system message. This is something to keep in mind. And after that, we have a user message saying extract essential information from our content. Then we initialize the empty responses string. We print some informational strings, and then we get the response in a streaming response fashion. We print it in our terminal so we can keep track of it. And we append each text chunk which we received, the string version of it, into responses, because every response that is returned from OpenAI now is a pydantic object. That's why we are stringifying it like this. And then because we are guaranteed to receive a JSON object due to the JSON mode, we just JSON load the responses and return that. So we can extract the list key, the extracted essential information list easily. And now we have another method called generate ideas, which takes in essential information and might take in user input. Otherwise, we are using a default user input. Our prompt is generate new and novel ideas based on this information. Actually, generate original and novel ideas based on this information while combining most of the elements from the information, because we will be presenting it with a variety of information. We do want a combination. You can feel free to change this any way you like. We can take in user input. Normally speaking, it's set to none, but at the end, we are asking the user if they want to override it. So then we take in user input. So if you do have user input, then we will use that. Otherwise, we are using our default message, which is this one. Then we are making a regular call to GPT-4 1106 preview saying you're a helpful assistant which generates up to 3 new and novel ideas based on essential information. Try to be original. And try to use most of the elements from the information, but do not be limited or greatly influenced by it. Create your own ideas. Feel free to modify this. We are entering a custom prompt here when you want to. but we have set the system message such as this. So you might want to change this if you like. Also, the prompt may play a role in it. As you see, this is the default prompt. So we give it the prompt and the essential information, then we get the streaming responses. So, and then we have our main method, which is run, which takes in a URL list and a user input if available. This runs the entire process of content extraction, essential information extraction, and idea generation. We initialize the URL list as empty list, and then we open the URL list file, which we will give at this time, and then read each line and create a list. And if shuffle equals to true, then we shuffle the list. You remember, we have set the shuffle URLs to true. Feel free to change that. After that, we call the extract content from the URL list. This will actually call our class, which we have imported. Remember, content extractor class from our content extractor.py file. After that, we'll have our entire list. Then we initialize an essential info empty list, and we enumerate over the content list. We are both getting the number and enumerating a number so that we can actually save each one of our essential information and generated ideas in a iterative fashion like this, as you see. And then we extend. We use the extend functionality of the list, method of the list, essential info.extend. Then we call the extract essential information on the content. And when this is returned, as you remember, we are JSON.loading it. And we know that this JSON object has a key in it called extracted essential information, which is a list. So that therefore, when we initialize the essential info list as an empty list, and we are extending it with the extracted essential information key of whatever this method returns, which is the result of our GPT call to extract essential information. Therefore, we will continually add to this list. When you're appending a list to another list, you want to extend it so each list element is added to the same list and not as a list itself. Then we call the generate ideas with the essential info list that we have and user input if you have any. Remember, you can customize the default prompt, and then we get the ideas. And after that, we open a JSON file enumerating the file name and write the essential information there with json.dump. And we generate a text file, we enumerate it again, and we write the ideas there. This is how we are able to generate this ever-growing list of ideas, ever-growing list of essential information, and new ideas generated from the ever-growing list of essential information. And then so this was the method to run this. We instantiate our class content idea generator with our OpenAI API key, which we have defined all the way up here. And then we print that the default request is, and then we specify the default request. Then we ask the user if they want to change it. If it is, if they want to use the default request, if they say yes, then we simply run generator.run with the file list of URLs we want to run. If it is no, then we take in a user input and again run it with the list, whichever file you want to run with, and then the custom user input. Just when you insert a custom user input, make sure that you include from the information column so it knows, because if you see here, this is our prompt and then we give the essential information. So you want to kind of write it in a way that points to the essential information. Let's run this again for fun. Here I have 3 Wikipedia articles, one for empathy, one for artificial intelligence, another one for Egyptian pyramids. We do need to enter this URL list _2 here. I'm not going to change the default message. So therefore, we can run it like this. I'm going to run the script, and when asked if I want to use the default request, I'm going to say yes. And now we're extracting the content from these URLs. And since we shuffled, Egyptian pyramids came out first, so we are going to extract the information from there and overwrite this first file. Once this is done, both the ideas and the essential information has to be generated. And here we go. And let's take a look at the ideas. The Archaeospace Launch Complex, blending the ancient understanding of pyramids as stairways to the heavens with modern space technology. This concept imagines a state-of-the-art space launch complex. Second one is pyramid power renewable energy plants. The mere immersive archaeological experience, taking advantage of virtual reality and augmented reality. So this is interesting. And then it added empathy next. If you look at the next file, we not only have the pyramids, but the empathy had been extracted. And now it is generating ideas based on both empathy and the Egyptian pyramids. I mean, why? You might ask, well, why not? We're just trying to have fun and see what it generates. Here it says Empath AI Archaeology Companion, combining the intrigue of ancient Egyptian pyramids with the concept of empathy and AI, develop an artificial intelligence archaeology companion that assists researchers in understanding ancient cultures. And then it keeps coming out with new ideas. So the first one was based on just the pyramids. Second one with empathy and pyramids, and third one is artificial intelligence, empathy, and pyramids. So this is pretty cool. So you can, like I said, modify, add any URL that you like. Just make sure that we are only looking for these HTML elements, the paragraph, section, article, and code. And here I have some of these as examples, but feel free to modify them and do let me know what you think of it in the comments. If you like to talk about large language models, please check out our Discord. If you do decide to become a patron, remember that I have over 160 GPT powered projects, and I also have the Everything GPT API course. So this one actually it's like a crash course, talks about the older OpenAI library, new OpenAI library, Everything Assistant API, and vision and speech examples. This is available at the $30 tier, so you will have access to that also. And remember, you can always search for my 200 plus free coding videos at echohive.live. You can search for anything you're looking for, such as AutoGen, for example. There's an instant search. You can read the descriptions and find the code download links. I hope you enjoy this project. Let me know what you think in the comments. If you like the content, please give it a like and subscribe for future videos to be notified of the future videos. And I'll see you in the next video. Thank you.